I'm Hannah Weiss, the Education Manager at the Science Museum of Western Virginia, and this is your Moment of STEM. And this week, we're going to talk about sunscreen. That's because right now, we're right in the middle of summer, and for me, summertime means a lot of time spent outdoors. And also, well, let's just say I can get a great sunburn going by thinking about the sun too hard. That's right, I love time outside, but outside time for me also means sun safety. And like a lot of people, sun safety for me means sunscreen. The science behind sunscreen is crazy cool. But before we get into that, it might be really awesome to explore just what sunscreen is protecting us against. So the sun is an obvious answer here, but it's really protecting us against UV or ultraviolet radiation. Now, ultraviolet radiation can be split up into 3 different categories based on wavelength or size. Those categories are UVA, B, and C. Really helpful and pretty easy to remember. Now, of these, UVC is not really something that we need to be terribly concerned with because it's mostly filtered out by our atmosphere and ozone, which just leaves us with UV, A, and B. Now, UVB is the one that most sunscreen is concerned with, and that's because UVB is most linked to sunburn. In fact, SPF, or sun protection factor, you know, those little numbers on your sunscreen, that actually refers to sunscreen's ability to protect or defend us against UVB. Now, that's not to say that UVA doesn't cause damage, because it does. However, the damage that it's linked to is a little different, in part because it gets a lot deeper into our skin. UVA is mostly linked to things like wrinkles and sunspots and aging. If you would like a sunscreen that protects you against both UVA and UVB, you need to look for products that are labeled broad spectrum. However, in the US market, there's very little regulation about what's actually required for a sunscreen to call itself broad spectrum. So it's really up to the consumer, you know, you and me, to figure out which products work best for us. But now that we know what sunscreen is protecting us against, we can really look at some of the chemistry, the neat science in the product, in sunscreen itself. Now, there are 2 main things that most sunscreens are made up of: organic and inorganic compounds. Now, organic compounds, those are the things where if you look at the ingredients list, they have really, really long names. And if you looked at their chemical makeup, they have a carbon atom in them. These work by basically putting something on top of our skin that can absorb the radiation, and then it kind of releases it through heat. Now, it's really cool that we have these. However, some recent research has actually linked these compounds to potentially damaging coral reefs. Now, the research is really new, and it's unclear how much damage these things are actually doing. But a lot of vacation hotspots and destinations which have reefs at them, like Australia and Hawaii, have either banned or begun putting legislation into place to ban the sale of sunscreens or use of sunscreens that are not reef safe. And this could even affect your vacation, even if you don't go snorkeling. Because if you do put sunscreen on and then spend your whole long day at the beach, coming back to the hotel and taking a shower probably means that some of that sunscreen may end up in the water. Once we've explored those organic compounds, all that's left are the inorganic compounds. And these are where sunscreen gets really neat. Because inorganic compounds, things like zinc oxide and titanium dioxide, have been in sunscreen for a while. But the way that they've been used has drastically changed over time. So if you think back to those like early 80s surfer movies, you know, the really cheesy ones where the lifeguards got that large stripe of white on their nose, that's zinc oxide. It's that really, really chalky, thick, pasty stuff. The way it works is by creating a layer, kind of like a jacket or a coat on our skin, that bounces the radiation back. However, that old style sunscreen, it was really chalky and heavy. A lot of people didn't like wearing it. So what researchers and scientists did is they made the particles smaller, a lot smaller, like nanoscale or nano-size smaller, so that when it goes on our skin, it still provides that fantastic thin coat, but the particles are small enough that it actually scatters visible light. We don't see it. So what this means is that in our sunscreen, if it has zinc oxide or titanium dioxide and it sinks into the skin, there are nanoparticles in there. It means that it's nanoscience that you can buy at the grocery store. So I'm Hannah Weiss from the Science Museum of Western Virginia, and I can't wait to hit the beach.